How to protect against ESD in cleanrooms. Best practice for static control by Anthony Chien, President of American Cleanroom Systems, with more than 40 years of experience designing, building, and operating cleanrooms. Founded in 1976, American Cleanroom System has built more than 750 ISO 4 through ISO 8 modular cleanrooms. Industry served includes semiconductors, electronics, laser, pharmaceutical, medical device, and industrial. We have a blue chip customer list including national labs and top corporations. What is electrostatic discharge, or ESD, and why do we care about it in cleanrooms? Electrostatic discharge is the sudden flow of electricity between two charged objects. Real-time examples of ESD include static shocks from walking on carpet or when you touch a Van de Graaff generator at the museum. ESD is a major cause of product failure in electronics manufacturing. 4 reasons why ESD must be controlled in cleanrooms. Number 1, ESD can cause serious damage to semiconductor chips and components, decreasing yield. Number 2, these voltage levels are well below what humans can feel, so they have to be measured with instruments. Number 3, ESD can cause particulates to be attracted to charged product and work surfaces, making the cleanrooms not working as well. And number 4, ESD can affect product misalignment in microelectronics or powder to cling in pharmaceutical manufacturing, affecting product accuracy and uniformity. How to measure ESD in cleanrooms. Typically, a handheld non-contact electrostatic voltmeter is used. Simco FMX004 will run between $500 and $1,000. The voltmeter measures the electric field above the surface. Holding the meter the same fixed distance from the surface means you'll get reproducible results. People run tests over the product, over their equipment, over work surfaces to see the field strength. You'll see values in a non-ionizer cleanroom for anywhere from 200 to 10,000 volts. Typically, people run regular ESD surveys in the cleanroom to ensure the ESD is under control. There are 6 major ways to control ESD in cleanrooms. The first and most popular is cleanroom humidity control. The second is proper grounding of work surfaces and equipment. The third is proper grounding of personnel. The fourth is use of static distributive cleanroom garments. The fifth is using static distributive cleanroom flooring and walls. And the sixth is to use active ionizers. ESD can be controlled in cleanrooms using humidity. You want the humidity not to be too high or not too low. Most people recommend keeping the humidity between 40 and 60% in your cleanroom. At lower humidity levels, the charges don't dissipate well, and measured fields can be 3 to 5 times higher than at good humidity levels. At higher humidity levels, ESD is lower, but then you have the problem of higher microbial growth, metal corrosion, and process control. Finally, humidifiers and dehumidifiers are used to control humidity in cleanrooms. People control ESD in cleanrooms using personnel grinding. There's 3 different ways to do it. The first is to wear static distributive cleanroom garments. Polyester cleanroom suits with carbon fiber prevent charge buildup on clothing. Second, the operators wear grounding wrist straps that attach to the workstation grounds to get rid of their static. And finally, operators wear grounding tabs on their cleanroom booties to make contact with static distributive floor and let their charge leave that way. Another way people reduce ESD in their cleanrooms is using static distributive walls and floors. Static distributive walls can include painted aluminum cleanrooms walls or static distributive clear vinyl soft wall curtains. Static distributive flooring can be heat welded vinyl, static distributive vinyl tiles, or static distributive epoxy flooring. There's a big difference between static distributive and conductive material. Static distributive values are higher and they allow the electronic charge to slowly leave. Conductive is much less resistive and allows for much faster discharge events, even to the point of putting operators at risk by making them the ground. In some cleanrooms, people use ionizers to control the ESD. The ionizers flood the air with positive and negative ions. The ions attach to any charged surface and cancel the charges. Common locations for ionizers are at workstations, wafer handling tools, and above pharmaceutical powder filling lines. Recently, pharmaceutical cleanrooms have become concerned with electrostatic discharge. Under CGMP, They're concerned that particle contamination can occur more often with ESD. Charge surfaces pull the contamination particles onto their products. Microbes travel via the charge to attach to the particles. Static can cause powders to cling to equipment or clump up, hurting process yields. And then static can cause particles to actually jump to the packaging material for the product, causing contamination. And then in some situations where there's a lot of flammable liquids around, static can even ignite the liquids. Thank you for watching our video on ESD in clean rooms. The author, Anthony Chien, has been with American Cleanrooms for 13 years. American Cleanrooms has been around since 1976 and is one of the top cleanroom builders in the world. You can learn more information on our website at www.americancleanrooms.com.